Hello, and welcome to the fourth and final video of Encouraging Engineering. Today, we're going to learn how to move a servo motor using a photoresistor. If you are more of an independent learner, there's slides in the description that correspond with this video. As always, let's talk about our components before we start. A servo is a type of motor that can rotate to specific angles, which it does so through the gear system inside it. This lesson will use a microservo 9G. Unlike previous lessons, we need to download a library to use this component. The download link will be in the description below. We'll talk more about how to do this in a few moments. Now, if you ever want to make a project with multiple servos in the future, you need to understand what an external power supply is. As the name suggests, it's when you use a different power supply other than the Arduino to power your circuit. A common example would be a battery pack. While the Arduino is usually good at powering your project, using components that need high power and current, like motors, cannot work properly with the Arduino alone. The Arduino is strong enough to control one servo for this project, but if you ever want to work with more than one, you need to use an external power supply. Additionally, look up the parameters of your servo you're using to make sure you are using the right power supply. The power supply should be able to support the voltage and current needed for the component and ensure that the Arduino and power supply are connected when wiring, like in the image here. Our second component, the photoresistor, is a special resistor that increases or decreases its resistance based on the light detected. This allows us to measure the light level of an area or room in our projects. Before we start coding, we need to download the libraries needed for these components. In programming, a library is a collection of code created by developers for the community to access. The components we're using need a lot of computing to work, so programmers created libraries to make them easier to use. To obtain a library, you can usually look up Arduino, the component you're using, and library. But to save time, I've included the library link in the description below. Open the Servo link and download the latest version of the files. They should be formatted as .zip. Then, go to your Arduino IDE and open the Tools tab in the top left corner of your screen. Click Manage Libraries to open the Library Manager tab to the left. Once it's open, go back to the top left of the screen and open Sketch. Scroll down and click on Include Library. Then click on Add.zip library. This should open your computer files. Here, go to the Download section and choose the library you downloaded earlier. After you select it, the section underneath your code should say Library Installed, indicating that you did everything right. To double check, look at the Library Manager and choose the Installed option in the filter. The downloaded library should appear here. Now that everything is set up, we can finally start the program. Once you've reviewed the components, follow the diagram here to set up your circuit. You'll need one Arduino board, one breadboard, 8 wires, a 10,000 ohm resistor, one servo motor, and one photoresistor. Pause the video if you need more time. When starting our program, we first need to call the library we just downloaded. We can do so by putting #include, >, servo.h, > at the top. Underneath, we can start by creating our variables. The first variable, called photores, will represent our photoresistor and use analog data. This means it must be assigned to one of the analog pins in the Arduino. We also need a variable to count the turns our servo will make. Up here, you'll notice that this isn't really a variable. Because of our library, we don't need to assign variables to the servo. Instead, we label this component as a servo motor, and we'll declare which pin in the Arduino it's connected to in the next section. In the setup function, we'll put the photoresistor as our input since we're using its data to move the servo. Underneath, we can assign the servo to a pin by using the function attach. We format it by using servo.attach with the Arduino pin in the parentheses. If you follow the diagram, this should be pin 7. Moving to the loop function, we're going to set up our photoresistor to measure light. First, we'll make a variable called light level, which will store the light value measured by the component. Next, we'll set this variable equal to analog read photores, which means that the light level variable will represent the analog data read from the photoresistor. Remember, we use digital data to tell if something is on or off, and analog data to read specific values. Moving down, We need to program our servo to move when the light is detected. We'll use an if statement to do so. In the condition, we're going to make it so that the servo moves only when a light level greater than 500 is read. Under the condition, we're going to make our servo move using a special function called write, with servo as the component we're controlling. We can only use this if we're using the servo library. We'll put the variable turn in the parentheses to represent the position we want it to turn to. Underneath, we'll use a delay function to give our program time to turn. Without it, our program will move too fast for the servo to react, causing some issues with the project. In the next line, we'll have the turn variable increase by 30 degrees as long as light is detected. This will ensure that the servo keeps moving. However, it will stop once it reaches 180 degrees, which is the limit for this servo's movement. Now, let's program what will happen when light isn't detected. If the photoresistor doesn't detect light, we want the servo to reset back to 0 degrees. Under the else condition, we'll use the write function again to move the servo back to 0 degrees. Then, we'll reset turn to 0 so it can increase again when light is detected. Once you're done, plug in your Arduino and test out your project. If your project isn't working, some methods for troubleshooting can be checking the Arduino is plugged in, checking the circuit setup, and looking over your code. Remember to have your library downloaded, and remember that the serial monitor can be useful for checking variables. If you need a refresher, you can watch Lesson 2 on this channel, or look at the link in the description. If nothing works, try to take a break and return to the project later. As always, if you're interested in learning more, some extension ideas with these components could be turning the servo to different positions based on light level, having a servo turn up positions corresponding to an RGB's colors, or making a passive buzzer make different sounds based on the light level the photoresistor measures. Be creative with what you know. Before we end, I'd like to thank you for your time and interest in learning Arduino. Though this is the final lesson in encouraging engineering, I hope you'll go out and find more opportunities to explore on your own. Whether it's through kits or simulators and books or online, there's a lot you can do to learn Arduino and build any dream project. Good luck on your future goals, and thank you for watching.